Hello and good morning dear students. So today is 18th of August, today is Tuesday, and yesterday we have completed exercise 9.4 separation of variables. In today's exercise we'll be learning more about separation of variables. The topic is reducible to variables separable. Okay, so sometimes what happens is that you cannot separate the variables directly. Even though you cross multiply, keep x, y, y together, you will not be able to separate variables directly. Okay, so in those cases we'll have to use this reducible to separation of variables. Okay, but for that we have to see the differential equation. So I've written out here, if the differential equation is of the form, this form dy by dx is equals to f is one of the function, and inside the bracket if we have ax plus by plus c, right, then you have to substitute this expression inside the bracket. Only the expression which is inside the bracket ax plus by plus c as v, substitute it as v, okay, and then take the differentiation, and automatically the whole differential equation will be able to be in separation of variables. And this is in your page number A917. Please go through it. Okay, page A917, and now using this we'll be doing exercise 9.5. Okay, so pause the video, note it down. Alright, so let us start exercise 9.5, question number 1. The question is, solve the differential equation. So one part 1, the question is x plus y whole square into dy by dx is equals to 1. As I told you, the form has to be in the form of dy by dx is equals to f of ax plus by plus c. The coefficient of dy by dx has to be 1. But out here we have x plus y whole square. So what we'll do, we'll drop this down to the denominator. Okay, so that we get dy by dx is equals to 1 by x plus y whole square. Okay, so now let us compare this equation with this equation. Both of them are differential equation. Out here the function is f, and out here the function, we don't have any function out here, but we have x plus y whole square. Okay, so hence the form we are getting is this, and the substitution out here will be assume v as x plus y. So let us assume and keep it as equation number 1. Let v is equals to x plus y. Now what to do? Differentiate with respect to x both the sides. Differentiate with respect to x. So therefore I will be getting dv by dx, which is equals to 1 plus dy by dx. Alright, now what will I do from here is, you find the value for dy by dx. So therefore dy by dx will be dv by dx minus 1. Okay, I hope you agree with this. The value for dy by dx will be dv by dx minus 1. Now I have dy by dx out here, and the value is dv by dx minus 1. So I'll use this in equation number 1. I'll put the value for dy by dx in place of dy by dx. I'll put the value as this, and this value I know it is v, and then we'll see. Okay, so therefore write down from equation 1. So from equation 1, the left hand side, dy by dx, what is the value? dv by dx minus 1, dv by dx minus 1, which is equals to, do you agree it is 1 by, the value for x plus y is v, so is it 1 by v square? 1 by v square. Okay, now what we'll do, you take your 1 to the right hand side, so therefore it will be 1 by v square plus 1, take the LCM, dv by dx, so you'll be getting v square plus 1 divided by v square. Okay, and now if you cross multiply it, now easily you'll be getting what? Separation of variables. So pause the video, note it down till here. Alright, now this side, so if you cross multiply it, you'll be getting v square divided by v square plus 1 dv, which is equal to dx. The variables have been separated, so I can use integration sign. Okay, so this side it will be x, but this side, if you see, the power in the numerator denominator is equal. I've always told you, when the powers are equal, try to make the numerator as the denominator. So add 1, subtract 1. On doing so, you can make two terms out here, and this by this is 1, and this by this is this. Okay, so integration dv is v, and this is a standard integral tan inverse v, which is equals to x. So we are almost done. Now what we'll do is, So once the integration is over, you can write plus c also. So the final step will be to substitute the value for v. So what was our v? X plus y, right? So therefore this will be x plus y minus tan inverse of x plus y, which is equals to x plus c. So on both the sides, x and x gets cancelled out. So therefore your final answer would be y minus tan inverse x plus y is equals to a constant. Okay? So pause the video, note it down. Alright, so question number 1, part 2 is very similar, you can do it yourself. And question number 2, part 1 and 2, part 2 is also quite similar. One homework I will be giving you from there. And now moving to question number 3, part 1. Okay, number 3, part 1 is this. I hope you can identify the form now. The coefficient is already 1. Okay, so assume this as v. The moment you assume this as v, take the differentiation dv by dx, 3 plus dy by dx. From here you find the value for dy by dx will be, which will be dv by dx minus 3. Very simple. Okay, and now from equation number 1, see, the moment I got the value for dy by dx, now put this value out here, and this is v already, so hence it will be dv by dx minus 3 is equals to v square. Okay, now take this to the right hand side, it becomes plus. Now it is easy for us to separate the variables. So vv on one side, x other side. Once it is done, please take the integration sign. Okay, now this integral, it is very easy, but this one also we can make in standard form if I write 3 as root over 3 whole square, right? So therefore this will be dv v square plus root over 3 whole square, which is equals to x. So the final step will be, I think so I can do this side. Okay, so I'm clearing this. So please give me the form 1 by a tan inverse of x by a, that is v by root over 3, which is equals to x plus and then constant c. Okay, you can even multiply with this constant root 3, so therefore tan inverse v by root 3, which is equals to root 3x plus root 3 into constant is always a constant. Okay, and finally put the value for v. So tan inverse v means 3x plus y plus 4 divided by root over 3, which is equals to root 3x plus c. Okay, you might be getting different answer at the back. The reason is that what they have done is they have taken tan inverse to the right hand side, it becomes tan. It is exactly the same thing. Okay, the examiner will not see the answer at the back. The examiner will see how well you have taken the substitution, after that assumption, and then putting the value, and then separation of variables, integration. That's it. Okay, so pause the video, note it down. Alright, the next one I'm taking is question number 3 part 2. 3 part 2 and 4 part 1 are similar. Okay, so 3 part 1 I'll do and 4 part 1 will be your homework. Okay, so the question is cos x plus y dy is equals to dx. Again the same thing, I've told you the coefficient of dy by dx has to be 1. So please take this cos 1 x plus y to the right hand side and bring this dx out here, so that we get this. Very simple. Now 1 by cos means sec, so sec x plus y. Equation number 1, I hope you have guessed the assumption. It is in the form, so x plus y equals to v. Differentiate, find the value for dy by dx. Again go back to equation number 1, put the value for dy by dx, dv by dx minus 1, alright, is equals to sec v. Take this side, so 1, now separate the variables, right, none. So now here we have to do something. So sec is 1 by cos, which I have written out here. We will be taking the LCM. We'll take the LCM, which is cos v. Alright, so therefore after we take the LCM, we will be getting numerator cos v divided by denominator cos v plus 1 into dv is equals to dx. So now the variables have been separated. So now we can take the integration sign. Cos v, so I hope I can write cos v plus 1 minus 1 in the numerator. So cos v plus 1 minus 1 divided by cos v plus 1 dv, which is equals to x. Right? So now this side I hope I can clear. So this is x. So please make two terms, cos v plus 1 and minus 1, right? So this and this gets cancelled out. So hence it is only dv when you separate, okay? and minus 1 by cos v plus 1 dv, which is equals to x. Right, so this is your v minus, again now tell me, cos v plus 1 or 1 plus cos v. I've given the formula in plus, right? So cos v has three formulas: cos square v minus sin square v. The second one is 2 cos square v by 2 minus 1, isn't it? So if you use the formula plus 1, it becomes 2 cos square v in the denominator, because cos v plus 1 will be 2 cos square v by 2. Okay, so the same formula I'm using out here, 1 by 2 cos square v by 2, which is equal to dv, right, is equal to dx. So 1 by 2 is a constant, so v minus 1 by 2, right, 1 by cos means sec, so this is sec square v by 2, dv is equals to x. Now integration of sec square x is tan x, I hope you know that, v minus 1 by 2 into tan v by 2 divided by half is equals to x. Now this and this 2 gets cancelled out, so therefore v minus tan v by 2 is the angle, okay, v by 2 is the angle, which is equals to x. Now finally what we'll do is we'll substitute the value for v, which was x plus y. So that completes our answer. Okay, so that's the last step. So putting the value for v, which is x plus y minus tan of x plus y by 2, which is equals to x plus any constant. So x and x gets cancelled out. So the final answer would be y minus tan x plus y by 2, which is equals to a constant. Okay, so I hope you are clear with the steps. If you are not clear, please pause the video, okay, rewind it and then understand. Okay, so pause the video, note it down. Alright, so we'll keep this much for today. In fact, this much from this exercise, okay? And your assignments from this exercise, I'm giving you 3 assignments. Question number 1, part 2, question number 2, part 2, question number 4, part 1. And if there's any ISC sum so far, yes, there is one ISC sum. Please refer to example number 2, important one, example number 2, part 1. Which is 2015, ISC 2015. The question is sine inverse dy by dx is equals to x plus y. I'll just give you the first hint. Please take a sine inverse to the right hand side, so that we get dy by dx is equals to sine of x plus y. So I hope now you know what to do. Assume v as x plus y. Finished. Assume v as x plus y. Differentiate, put the value, integrate separate variables, finally put the value for v. Okay, very simple. It's an important one which has already come in ISC 2015. So please go through all these 4 sums, complete the sums and send it by tomorrow. Okay, any problem you have, you can ask me in WhatsApp. Okay, only a few students are doing that, so I want you all to, any problem, please ask. Okay, thank you, bye bye.